Okay. So are we audible now? Did we miss all the introduction?
Let me just see. Just introduction must be missed, but I think we can start now.
Did you want to go
It
again
says
from the top?
it's yes. So I'm just seeing how we can. Yeah, I can see the screen now. I think you can start now, Kalyan. As an
Oh,
audience, I
okay.
can see that the screen is live. Yes,
Okay.
we are live
All
now.
right. Hey, good evening, everyone. Welcome to SNEA India webinars. It's been a while since we had webinars, and especially from SNEA India. It's glad to restart SNEA webinars again. Just to in case there are people who have joined SNEA in recent times, SNEA is an industry organization that focuses on technologies relating to handling and optimizing data. It includes experts from all over various industries and corporations. There are over 50,000 worldwide IT end users and professionals as part of the community. The value of the participation is mainly to influence the industry and collaborate across boundaries and demonstrate leadership in the technology and sustaining standards. With that, we move on to today's webinar, which is How is Data Harming Your Health by Matthew Hardman. Matthew is a Chief Technology Officer for Hitachi Vantara in Asia Pacific. He has worked across various technology companies like Microsoft, VMware, LinkedIn, and so on. Matthew's focus and his team's focus is mainly to innovate in the space of data management to enable application experiences that range from on-premise transactional systems, edge, hybrid, to data analytics, and latest in AI. Matthew is a passionate believer in people development, raising awareness of sustainability, as you can see with his talk today. And when he gets free time, he is an avid gamer. So let's, looking forward, Matthew, looking forward to your talk. Go ahead with your talk today.
Thank you very much, and really appreciate the opportunity to be here. From what I understand, first webinar in over a year. That's an incredible honor, and I feel like I've got a lot to live up to. So hopefully we can make this fairly enjoyable and engaging presentation today. Look, the title's very dramatic, but we are talking about environmental sustainability, and we probably all, want this to kind of work for us, right? I mean, it might be because we have families and kids that we want a future for. We live and breathe inside an environment that we want to be able to enjoy. You see the news all around us. There are many reasons why environmental sustainability is something that's incredibly important. The challenge I think we face is that you can't point to one particular thing and say, well, let's just fix that and everything else will be fine. Environmental causes are very complicated. You can look at it from a number of different angles. You sort of talk about a lot of the efforts that governments are actually making, and government bodies and the entire countries, what they can go ahead and do, down to organizations, down to individual actions that you and I can go ahead and actually take. Personally, I'm the one person that walks around my own home and yells at my kids and say, turn off the bloody air conditioner when you're not in the room because you're burning them through the planet. And they're like, oh, I have to get up and turn things off. But I mean, that's the reality. Like, there are small changes that we obviously have to be able to go ahead and actually make. But when we talk about this sort of situation, what are some of those changes that we can start to affect going a level higher, right? How do we start thinking about it from an organizational point of view, a operational point of view, and specifically what's going on in the data center? Now, there's probably many things that you're going to see here today, which you're probably well aware of, right? I mean, there's certainly a lot of stuff happening in the press, but I'm hoping that there might be one or two nuggets of information which may be beneficial to you in terms of the things you might go ahead and actually do, the choices you might go and make, or some of the sources of information you might leverage to help you make an educated decision on how to have a positive effect on environmental sustainability. So let's get started. And if you have questions as we go through, please don't hesitate to ask. I will try and sort of watch the chat at the same time and see how I can go ahead and actually answer questions as we go. But please forgive me if your question's in there and I don't get to it immediately. Okay, so agenda for this evening, I don't have a lot of topics. I'm going to go into some of the different areas, but we want to talk first about how do you define sustainability. And this is important. I'll tell you an interesting story about this one. We talk about scope and scope emissions, and this is how we start to define the various levels of impact that we would have in terms of environmental sustainability. Then we're going to start drilling into the data center and potentially strategies that you can actually adopt to help you consider your energy consumption inside the data center. And again, some of these things are aspects that you may have already been doing inside the data center, but how do we take that one step further? So first off, it's important that we understand that sustainability is not environmental sustainability. Now, I've been burnt by this myself. When I started to really get into sustainability and talk about it with different executives, I got called out in probably one of my first presentations. I came out very bold and said, "Hey, let me tell you about sustainability and how we're going ahead and actually affecting it. And this is what we're doing." And this person put their hand up and they said, "What's sustainability?" And I said, "I don't know what you're talking about. What do you mean, what's sustainability?" Sustainability. And this person said to me, "Well, you need to understand that there's environmental sustainability, there's economic sustainability, and there's social sustainability. So which one are you actually talking about?" And it was a very humbling experience because I kind of felt like, you know what? I haven't really truly understood what are we talking about when it comes down to sustainability. So these days, when I do talk to people about sustainability and data centers, I'm very specifically about calling out environmental sustainability. But it is a complicated space when you start to think about all of the intersections of the various types of sustainability that you come across, right? So sustainability in its totality is made up of those three areas: the environmental sustainability, the economic sustainability, and the social sustainability. So, environmental sustainability, obviously, we're going to go ahead and actually talk about it today, but that's really about the world we live in from an environmental point of view, the air we breathe, the water we drink, those sorts of things. Economic sustainability is really about how do we create the right economic conditions for people and businesses to be successful? How do we make sure that the way that we execute our business operations is done in a legal sort of way or a compliant manner, right? And in our social sense, our social sustainability is what are we doing for communities to be able to help them be successful, and rights to education and things like that. Now, what becomes interesting is that all of those different areas of sustainability start to overlap. And so you start to get into these sort of sub areas: socio-environmental sustainability, ecological economics, socioeconomics. So sustainability is very, very complicated. And I know personally, some of the things we've been looking at, like there's lots of different sustainability reports. You talk about environmental sustainability, it makes up one section of a much greater area of responsibility. There are things to be considered such as modern day slavery. And that's a sustainability issue both from an economic and a social point of view. But it is something that's a real problem that organizations need to be able to go ahead and actually deal with. So I guess when you talk about sustainability, it's important to be very, very clear and upfront that the sustainability that you want to talk about fits into where these areas actually are. And so I'm going to focus mostly on the clear environmental sustainability at this point and how businesses and yourselves can make the right sort of decisions. Now, as we start to break down into environmental sustainability, we start to focus on an area which is typically on things like greenhouse gas emissions and how you start to have an impact on sustainability. Now, of course, there's, again, lots of different areas that you might look at in terms of environmental sustainability. It could be water consumption and pollution and those sorts of things. But one of the big ones when it comes down to a lot of measurements is greenhouse gas emissions. And greenhouse gas emissions, the way they measure the generation of those greenhouse gas is on the scopes approach. And this is a very much an industry perspective. It's the 3-scoped approach. So direct emissions, indirect emissions, and other indirect emissions, right? So 1, 2, 3. Now, scope 1 is typically the emissions of greenhouse gases that you would produce through your daily operations, right? So you're running a business. It's the greenhouse gas emissions that are produced by things that are completely under your control, right? So the operation of the lights and gases and all those different things inside your organization. These are the actions that you can take to be able to address greenhouse gas emissions. Scope 2, on the other hand, is the indirect emissions that you create by purchasing electricity from different providers. So if you think about this, if I were to go and produce, or if I were to go ahead and actually procure electricity from a electricity provider who creates electricity via the burning of coal, their greenhouse gas emissions would be fairly higher, right? So their scope 2, the scope 2 as an organization, if I was the organization, my scope 2 emissions, because I was using electricity from a coal burning power producer, would be much higher than if I were to go and get electricity from a company who generates electricity via solar farms or wind farms and things like that. So the choices you make in terms of the electricity providers to provide that power to your organization is your scope 2 emissions. Now, scope 3 emissions are the emissions that are produced which come through your value chain, right? So these would actually come through more than likely when you partner with different organizations. So let's say, for example, let's do something really, really simple. If I go ahead and actually buy paper, right, and I want to obviously reduce paper, like the usage of paper in my organization would essentially be could potentially be a direct emission. I want to reduce my paper consumption. And maybe it doesn't have necessarily lots of greenhouse gas emissions, but there's something that's there. But the production of that paper, the company that produces that paper, and all of the ways that they consume electricity and what they do in the environment, that creates greenhouse gas emissions. So when I choose to work with a particular partner to consume their service or their product outside of the electricity generation, the emissions that they actually create are those scope 3 other indirect emissions, right? So you can see the complication of this challenge, right? So scope 1 is what you can directly control based on the way you operate and what you go ahead and actually do. Scope 2 is the way the electricity providers are actually producing electricity, and then what their greenhouse gas emission actually is. And you kind of have control on that as well. Maybe not control on how they generate electricity, but you have choice in the electricity providers you work with. But your scope 3, when you start thinking about the value chain and the partners you go ahead and actually work with as part of what you offer, this is largely probably the most challenging one to be able to go ahead and actually work with, because you're not just looking at what you do and some of the simpler choices you make electricity providers, but it's everything the companies that you work with and how they operate. So most of the time we sort of see that scope 1 and 2, you can make educated decisions, you can have a better level of control, but scope 3 emissions are very, very tough. And there's actually, there's a whole range of different articles. One of the ones which I love to be able to use when I explain to people about scope 1, 2, and 3, I'm going to show this in the screen here, but Deloitte actually has a fantastic article where they've written this, and hopefully this is coming up on the screen. They talk about scope 1, 2, 3 emissions, right? So you can sort of see they talk about the definition between them. But they've got this really interesting 5 points around what is it that you need to understand about scope 1, scope 2, scope 3, right? And so as they sort of say, scope 1 and 2, much more in people's control, right? You can actually do things and make choices to control that a little bit better. Point 2, there's choices and things you can do to actually get to net zero. But where they see the biggest challenge is in scope 3. Lack of control. This is where most of the impact actually is across an organization, because one organization doesn't work with just one organization. It probably works with multitudes of organizations. So the impact that one organization has to its partner organizations can be exponentially created when you talk about greenhouse gas emissions. And being able to address this is where it comes down to point 5. This is really making sure that if you're going to go ahead and actually get to net zero, you've got to try and really understand your scope 3 emissions. So an interesting way to think about, and this is probably why sometimes we talk about environmental sustainability, it is quite complicated, right? You just don't look at what you do. It's the impact your business has across a number of different areas. And so you have to start then thinking about, what is it that we can go ahead and actually do to have a positive effect across these different scopes of emissions and things like that. So I'll just bring the slides back up. There we go. So let's more specifically talk about data centers, right? And how do data centers actually impact? And there's probably the 2 most obvious ways that you would actually see an impact on greenhouse gas creation is in construction and operation. There's probably a third one if you stop and think about it, and that would be around data center retirement, right? So when you actually retire a data center, the actual deconstruction of that data center would also have an impact in terms of greenhouse gas emissions. Some of that would be basically just on tearing it down, but then also the practices you would actually employ to retire the infrastructure. You know, how do you think about retiring the materials? How do you start retiring the infrastructure, the racks, the servers, the storage, all those different things? How does that actually play into it? But for today, I'm going to focus mostly on the construction and the operation. I will probably focus a little bit less on the construction. I'm definitely not a construction expert when it comes to building data centers. I'm going to focus a little bit more on operation, but I think it's interesting to have a look at the construction of data centers because, you know, many people are looking at how do I start to scale back my data centers? But interesting to find out where there's new data centers being built and some choices that can be made in that particular space. And we're seeing some good innovation coming from the industry in terms of new ways to do less greenhouse gas emissions when they build up a data center. So when you think about what is actually made up of how someone builds a physical data center, and this is really just the physical construction of the data center. It's not the acquisition of the racks, the storage, the compute, all those different things. This is just a physical building. What you can actually see is all the different aspects of the fundamentals of a data center to get up and running. And when you start to break it down, there's a few things which keep coming back over and over and over again in the construction, which would be fairly obvious when you sort of think about it. When you're building something that's fairly robust, like a data center, something like concrete is absolutely essential. And as it turns out, a lot of it is a massive contributor to the actual greenhouse gas emissions that are being created here. So if I look at this, concrete comes up in the foundation, concrete comes up in the flooring, it comes up in the external walls, the stairs, roof, a whole range of different things. And where we see that concrete coming up, it's pretty much the highest percentage of CO2 gas creation in terms of the production of CO2, right, in that process. So, you know, there's obviously an opportunity for organizations, or especially the manufacturing industry, to be able to do better in this space of utilizing concrete to help them address CO2 emissions. Now, this doesn't mean, okay, we have to get rid of concrete and try and go for something more simplistic. I mean, is it all metal? Is it going to be plastics and things like that? Certainly, we've seen some very interesting efforts from companies to look at containers that people go ahead and actually use. There are some people have put metal boxes into oceans to be able to go ahead and actually do that. But I don't think we're necessarily going to get away from mainstream data centers anytime soon. But there have been efforts to rethink concrete, which I think is fascinating because there is an opportunity to do better in this particular space. So Microsoft, and I know we're not meant to talk about vendors too much, but this is just an interesting sort of study that they were testing with data centers. And I used to work for Microsoft. I'm not there anymore. So I think hopefully you're going to let me get away with this one. But they were actually looking at the production of their data centers. Right? If we talk about data centers, Microsoft, Amazon, and Google Cloud, they're obviously investing in lots of data centers around the place, but they're looking at new methodologies and approaches to producing concrete for data centers. And I thought this was actually quite interesting because, as they say, most concrete, as the production of concrete, not just the construction of a data center. So we talked about the construction of a data center and how much of an impact that actually has. But if you come back and think about the creation of the concrete that goes into the construction of the data center, that tends to become a massive contributor to greenhouse gas emissions through carbon dioxide emissions in the process of burning energy or burning fuel to heat the kilns to go and produce the concrete, or through the chemical reactions when they actually heat up limestone as a key major ingredient for concrete as well. So that production is quite dramatic when it comes down to greenhouse gas emissions. So Microsoft is doing some very, very interesting things to go out to the coal companies who are creating some of the ash from their production and utilizing that as a part of their concrete creations. So, they're looking at a way of taking the waste materials from other companies to become a part of their concrete mix to eliminate the very taxing processes that are made today to create concrete. So I thought that was very, very interesting in terms of ways as people are building data centers, they're starting to think about the materials that are going into the physical data centers themselves. So interesting approach. Now, moving on to data center operations, and this is really where the crux of a lot of the conversations I'm having today. It's really about, once I've got that data center built up and I've started to bring in the equipment, where does the real power use actually come through, right? So obviously the power consumption really goes back into that scope 2 emissions, right? So I'm consuming power. I've got to make an active decision as to where I'm sourcing electricity from, but what do I need and what is generating the actual requirement for that power? Now, when we look at it, it's broken up into a couple of different areas. There is the actual things that need to be powered, and then there's the environments that need power to support it, right? So you can see cooling and power on the left-hand side. This is kind of the stuff you need to be able to go ahead and actually operate the data center. And then the actual components themselves, right? Storage, networking, and servers. Those are the physical components which really require the electricity. So even when we look at storage, network, and servers, certainly they are also going ahead and actually having a tangible impact on things like cooling and power as well, right? So obviously the more you actually have inside your data center, that's obviously going to require more cooling, right? So it has a ongoing effect inside the actual organization itself. So when customers then start to think about the acquisition of infrastructure to be able to power their data centers, or at least power the applications, you want to be able to guide them in ways to make educated decisions on how they should go ahead and actually do that. Now, one of the ways that organizations are really starting to look at this is through industry body certifications. And again, not something which is totally fascinatingly new. These have been around for a while. I want to talk a little bit about Energy Star. Energy Star is the one which is really backed by a lot of governments that are international. But there are also other ones around the world. I work a lot with companies in Japan, and they have a standard called CFP, or carbon footprint for product. And what they're able to do is to look at the entire life cycle of a product and say, okay, based on raw material acquisition through to shipping to a destination, through to operations, through to recycling, what is the entire carbon life cycle or greenhouse gas emission life cycle of that particular product? And what I find interesting about that is it's not so much you just submit your data to the body and they just publish it and it all goes up there. It's also independently audited as well. So Japan takes this stuff very, very seriously when it comes down to carbon emissions and greenhouse gas emission. Energy Star is another one which is a much greater visibility for a lot of organizations. You've more than likely actually seen the Energy Star logo on certain products that you've gone ahead and actually utilized before. What's interesting is that they have taken a leaf out of this organization's work to implement in the way that they track the efficiency of the data storage products. So what they look is there's a certain measure called IOPS per watt. And, most of the time when we talk about things such as storage, we typically talk about, how fast does the storage actually run? What's the IOPS you're going to go ahead and get out of that? It's 5 million, 10 million, 30 million IOPS, right? High performance and things like that. But now we're starting to see a greater level of recognition from the industry to say, well, how do I measure that performance in terms of wattage, right? So what is the amount of IOPS I can get based on electricity being consumed? Because the higher the IOPS I can get per watt, obviously is a demonstration of the efficiency. Now, again, it's not the most singular view of what is great for the environment, but I think it's a great effort to be able to look at some measurable metrics. Does that sound right? Measurable metrics, but some metrics which can be utilized in helping making an educated decision. And so I wanted to show you how you could actually do this for yourself and have a look at it, only because, a few times I'd seen the data myself and somebody said, if you look at the Energy Star website, you can actually see some of the data around different storage aspects and how well they perform. And I must have spent maybe half a day trying to work out how to decipher the Energy Star website. It's not necessarily the most user-friendly way to be able to go ahead and actually get it. So while you're here, I thought I'd sort of quickly take you through how you could actually do that. So I'm going to go back to sharing this tab. So if I come here, this is the Energy Star website, right? So it's the main site. And what you typically see when you go to it first, it's typically a lot of consumer technologies, right? Washing machines, dryers, there's commercial dishwashers, I guess. But the things you would probably see as a consumer. But when we start to go into some of the other products, if we go to see all products, you start to see a much greater level of clarity in terms of different devices, right? So we've got there heating, cooling, appliances, water heaters, lighting, building products, office equipment, blah, blah, blah. Now, even now, trying to look for something which is like data center storage, it's not necessarily evident, right? And so what you almost need to go and do is to come down here to, where is it? Product Finder, right? So once you get into Product Finder, click that, you'll get down to then another level of granular detail for all of the different equipment that Energy Star actually has. And so you'll see here up the top there, we've got data center equipment. So we've got enterprise servers, large network equipment, data center storage. So I typically work in a lot of data center storage. So I click on this particular one here, and what we start to get down to is all of the different servers, also all the different storage arrays which can be utilized. And obviously Dell's got a lot submitted here, so they're taking up the entire front, but there's at least sort of about 4 pages of different data center equipment. Now, if you wanted to do a comparison, sure, you could go through and, check every single one. So I can check on this one here and have a look at it. And I can go through and look at the information about the product itself, like what's the file IO, what's the disk set type. So NVSS disk set online 4 is typically your sort of mid to high-end storage, SSD based. And then if you go down to, this one doesn't have it. Okay, let me go back. Let's try another one. I think. Right, this is not a failing demo yet because I'm looking for a certain number that's actually on here. There is there's a thing called the trans-optimal point hot band workload number, and that's a measure of that efficiency. Now, okay, maybe it doesn't have it on some of these older ones, but what I can do is show you how you might go ahead and actually analyze this, because obviously you don't want to click through each individual one. What you'd rather be able to do is actually have a view of everything all in one shot. And so if you go up the top here, there is actually the ability to download all the data as an Excel spreadsheet and start doing your own filtering. So I won't click this here because it'll download. It's not a huge download, but I've already got it downloaded and open here. So I'm going to stop sharing and I'm going to go and share this Excel spreadsheet. There we go. So I'll just drag this over so I can see my window in my Excel spreadsheet. So this is the data extract that comes from that Energy Star website. So it's a fairly lengthy amount of information that's actually there. To work with this and make it really simple, what you can do is just select everything. Sometimes Excel likes to be a bit challenging. So let's go down and across. And I'm going to go ahead and actually format this as a table. Right. And now we can start to filter across all this a lot quicker, right? So I might be able to go through and say the product type. Let's go for that high-end mid-range storage. So we'll go through and filter by NVSS disk set on line 4. Click on OK. And then we've come down to that mid-high range area of storage. And if I go across, I'm looking for my trans-optimal hot band point. This one here. There's a couple of different variations, but this is the main one, the trans-optimal point hot band workload test. And I can go ahead and sort by largest to smallest. And from there, what I can actually do is see which ones actually have a higher level of efficiency in terms of the power they're actually consuming. So you can see here, the highest one is a 368.86 as IOPS per wattage, and it goes all the way down to 30.2. So I won't go back and show you who is actually there because, again, I don't want to go ahead and actually say, okay, let's go rank the different vendors and try and, not say badmouth anybody, but I'll let you go and discover that yourself. But it does give you a way to have a look at the latest submitted data at the Energy Star website and do your own comparison in terms of what does that performance actually look like? Like, what's that performance per wattage? So if you're thinking about the environmental impact of the acquiring of data storage, this is a great way to go ahead and actually have an independent view across all the different vendors in terms of what that level of performance for environmental impact might actually look like. So hopefully that's a good tip that you can utilize to get insight there. So let's actually jump back. Actually, the one thing I should say, that's that number, the actual trans-optimal point, it's a terrible name, trans-optimal point hot band workload test actually came from the Emerald Power specification from SNIA. So the work that this organization actually has done has really gone into building out a way to measure the impact and the performance of storage inside our industry today to help people make a much better educated decision. So I should be saying very much thank you to this organization for helping us push the industry forward to giving us a way to start looking at this from a metric standpoint as well. So all this information totally available to you as well. Now, that's a start in terms of actually, look, what's a practical thing you can go ahead and actually do. As we start going to some of the other practical ways as well, some of these things are going to be fundamental, right? So what can you look at doing when it comes down to rationalizing server usage to helping you to reduce the amount of greenhouse gas emission you would have? And again, we've been talking about server consolidation for a long time. I think there's still an opportunity for us to go back and continue looking at that. I still think as many organizations, and I've had the opportunity to work for hardware vendors and software vendors, and I've spent a lot of time at VMware. Sometimes we are very, very precious about the resources that are utilized for virtual machines. We still tend to over provision. I think if we were really thinking about, approaching the resources that we're actually utilizing in our environments from a much more scarce level, we probably could squeeze out more of the resources out of the virtual machines. Certainly, there's definitely a lot of effort that could be done to retire virtual machines that just aren't being utilized. There is quite often this hesitation for people to say, well, do we really need this, or do we really have do these resources actively really have an impact on our business overall? Like, is it just one passionate person who says, I absolutely need this and it has to have all of this virtual memory and all of this virtual CPU, because if you don't, then I'm going to complain? at some point we need to make rational decisions, because before it was about passion and a sense of status and ownership, but now we really have a reason to want to retire some of these different things. So I think the ability for us to look at what are we doing today in our server environments, and are we actively retiring the things we don't need to keep running? I think that's absolutely important. And while I would actually sort of say it's important here in terms of your on-premise data center, it's probably equally as important in the cloud as well. So if you're pursuing a strategy with cloud providers, really having a aggressive form of assessment of your cloud resources and saying, okay, do we really need these ones? Are we actually over provisioned? I will talk a little bit more about this later on, because it is something, when I've spoken to different CIOs, they're actually starting to see it as a bit of a challenge. So resource over provisioning is one thing. The second one on the right-hand side is how you're utilizing certain technology for the point it should really be for. And again, this is something that we've seen in a lot of big private data center environments, and especially with the introduction of hyper-converged infrastructure. I mean, the promise of hyper-converged infrastructure is great. You know, the ability for you to be able to rack and stack lots of servers and have that level of resiliency and redundancy. So if one server goes down, the software itself is intelligent enough to be able to rebalance all of those workloads without interruption, and then you just rip out the faulty server and maybe throw in a new one and get up and running again. Hyperconverged is great. But over time, there's been many organizations who, as they've grown those hyperconverged environments, what they've come across is they've required a greater need for storage than they have needed for compute. And so some of those hyperconverged nodes have essentially become purely there for storage versus compute and storage as that sort of cluster. Now, of course, there could be reasons why you might have gone down that path and said, okay, you know what, I'm really going to go ahead and actually focus just on having my storage and compute together in a full hyper-converged infrastructure environment. But we also see customers who are looking at levels of efficiency where they want to take the storage aspect of their hyper-converged environment out of the hyper-converged environment and put that into a more centralized data store, because a centralized data store can give them levels of efficiency and operational efficiency as it relates to environmental impact that they might not necessarily be able to get from running a whole range of different servers. So certainly this is an architecture which big vendors like VMware obviously support the ability to offload the storage to an external storage array, and then you're able to utilize the technologies on the external storage array to give you the best outcome from an environmental perspective. So that's something to look at as well. So even as you start to virtualize and consolidate, think about what parts you're consolidating. A couple of other areas as we start to come towards the end, so I know we're going to run out of time quickly, or might run out of time for questions. The leveraging of modern storage technologies. Storage technologies are continually evolving over time, but sometimes there is a hesitation or an apprehension to adopt certain aspects of technologies. So one of them is things such as deduplication and compression. And people will sort of say, oh, you know what, if I utilize deduplication or compression, that's going to have an impact on the performance of the array. It's going to require some resources to be able to go ahead and actually process that. And I would tell you that, yes, that is true. It will actually impact the performance of the array. But to be honest, when we say impact the performance of the array, we need to also understand how much does that actual impact performance going to be. We've actually seen with many organizations that the technologies that they utilize for things such as deduplication and for compression, the performance impact is sometimes negligible, right? There are some times where we've had to sort of look at it and make some assessments in terms of, hey, is this going to be dramatic? But these technologies over time have gotten so much better. We're starting to see now how we offload a lot of the processes from the general MPU to the actual dedicated hardware assets to create or to operate that data set, compression and deduplication. So that's being offloaded to specific pieces of hardware, which will speed up that process overall, at least make it much more efficient, so it has less of an impact on the actual storage arrays. Another thing which we see a lot of people doing, and this is supported by many different vendors as well, is also storage virtualization. And we recognize that some customers, they've invested storage technologies for quite some time. They've sort of built this up, and they've purchased from different organizations, and some storage has over time just been part of the infrastructure but hasn't been necessarily upgraded. Some of the aspects of storage virtualizations let you bring a more modern storage to the front of where you're storing all of your data, and then start utilizing that to provide more modern capabilities to some of your old storage. So you're able to start to aggregate some of your older storage and enhance it with newer features by virtualizing the storage behind that. So, I would look at some of the things that you can actually do with your storage today and say, can I look at compression and deduplication in today's environment and actually get some benefits on that? And then, we are very, very passionate about doing that because of the environmental gains. But there's also cost of operations and efficiencies that you can actually get at as well. And then also the modernization of older storage is a great way to go ahead and actually do it. Let me just sort of say here, I got a question here from Sandeep. What is your perspective of having an industry standard SLA definition for sustainability SLAs like watts IOPS or watts per terabyte when defined against a given workload at a given sea level? I'm not sure, Sandeep, just the last word, sea level, just throws me. Like, you're not talking about a height from the ground, right? Sea level, is it just a different word I'm looking at? I mean, certainly to your point, having an industry standard for sustainability, I think is super important, right? I mean, anything we can actually do to help organizations to, look at the way that they're actually approaching sustainability, and also have a comparative way to look at organizations within their own industry. Like if you said, for example, hey, manufacturing organization, here's what we're doing from a sustainability standpoint, and how do we have certain measures that we can use to compare against other organizations. So if I've got one automotive manufacturer that is working in working in the same industry with other automotive manufacturers, can they actually base some of their sustainability metrics against each other and actually look at how they can go ahead and compare and look for areas of improvement? Because certainly sustainability is not the first thing that organizations have come across where they're looking for ways to compare against each other and look for ways to actually optimize and best practices. So, I would love to be able to have a much more common industry standard definition for what sustainability actually looks like. I think the challenge is that sustainability, and if I use your words just here, sustainability itself, again, we're looking at environmental, economic, and social, right? Those are three big things. And then if we start looking at environmental alone, then you start thinking about, well, what exactly are we talking about from an environmental point of view? Is it greenhouse gas emissions? Is it water pollution? Is it what are you doing around natural environments and things like that? And certainly you see lots of different organizations have different aspects. So we may not be able to get to a single standard SLA. Maybe it's more guidelines that we need to get to. I'm not sure if I've answered that question really well. Like I say, it's a perspective. That's my perspective. And I think a lot of people probably have their own perspective in terms of what needs to be done. But I kind of hope that if we're all moving in a common direction to actually know that this is a challenge and things we can actually do to benefit, then it's better than nothing at all, I think. So if there's more around that question, I've got my email and everything at the end. Please shoot me an email and we can have a longer chat about it for sure. Last thing on the right-hand side, one of the other areas which is worth considering as well is some of the storage technologies that you choose for data. There are many instances, I think, where we sort of see customers who have an approach to what they do when they purchase storage, and they kind of go through the motions of, I buy block storage, and that's what we've always gone ahead and done. Or I buy NAS, for example, and go ahead and actually do that. But while those technologies have been around for a while and they're great, they provide high levels of resilience, redundancy, performance, all those different things. the data types that we're starting to capture now are varying faster than ever before. And I think one of them is you start to look at it's just like data and machine data. I was in Japan last week at a executive briefing for some Indian customers, and we were talking about data versus machine data. You know, data, if I put this as an example and sort of said, somebody asked me a question, what's the weather like today? The answer from a data point of view would have been 27 degrees Celsius. But the machine data that I would have captured around that would be something along the lines of, now, in order to answer your question, I'm going to inhale the oxygen into my lungs, and I'm going to use that to actually inflate my lungs. And then as I'm going to use the muscles to push the air out of my lungs, it's going to come back through my throat, and it's going to go through my vocal cords, which is actually at the same time going to connect up to my brain to be able to get the information. You know, the data point is tiny. It's nothing, right? 27 degrees. But if I explain the entire process, which is like the machine data, all of a sudden I've got this stack of data, which is absolutely massive. And so we are collecting data from such a massive variety of different services, different sources, different types than ever before, that some of the more traditional data storage technologies just aren't really tuned and optimized to be able to go ahead and actually do it. So I think there's also an opportunity for customers also to have a look at varying data storage technologies, especially around unstructured data, that is more tuned to be able to be utilized for those sorts of workloads as well, you know, from a deduplication angle as well. So, you know, look at different types of storage that are more optimized for the data type that would go ahead and actually use. Now, one of the last ones I would talk about towards the end, you know, a lot of people would sort of say, well, hey, you know, what if I go to the cloud? Like, if I go to the cloud, I'm going to be better from a sustainability point of view. And yeah, look, I would argue that there are obviously going to be benefits from energy efficiency and greenhouse gas production efficiency, because you're working with an organization whose primary goal and operational focus is to go ahead and actually run as a data center and do it at scale. So you're looking at shared resources, shared equipment. They can probably go ahead and actually produce electricity better for a very optimized experience in the data center and things like that. It also, if you're really going ahead and actually measuring your scope of emissions in your greenhouse gas creation, you can start to see where that would actually transition. So, you know, you would move some of your scope 2 emissions down to your scope 1. Right. So if you remember the scopes of emissions, scope 1 is your greenhouse gas creation, which comes from your daily operations. Scope 2 was the greenhouse gas emissions that come from, you know, the choice of electricity providers. And then scope 3 is the other indirect, which goes from partners. If you were to shift all of your workloads from your data center to a hyperscaler, you're effectively taking a lot of those data center electricity costs from scope 2 and moving them into scope 1 to be able to actually look at it from this is what we're creating from an operational point of view, because you're still operating that cloud. You're still accountable for the greenhouse gases which are going ahead and actually being produced. Challenges around that typically tends to be, how clear do you actually have in terms of the energy consumption of those data centers? Yes, I will actually say that they're getting better with their tools and their reporting to be able to get to that. But when you start getting into a shared infrastructure, it's a little bit more unclear as to how you might look at your particular scope of it and how it's being utilized. Like I said, the tools are actually getting better. The other side of it is, I think when we look at data centers, which are typically privately owned, you have a little bit more control on how much those resources are actually being consumed, right? You kind of have an aspect of restrictive use, right? You don't have infinite scale inside your data center. But the hyperscalers in the cloud, they can very quickly give you that effort, or they can give you that ability to have infinite scale. Now, yes, you could argue that you can put cost control measures in place and all those different things, and people can be responsible. The problem is that sometimes people aren't necessarily super responsible. I've had conversations with one particular CIO where he holds his developers accountable because his concern is that as they moved into the cloud, they've got developers who kind of think infinite, and they're not necessarily thinking about optimized. In the same way they would think about, okay, I've got restricted resources inside my own data center, so I've got to be think about scarcity of resources when I develop and how I write my queries and all these different things. I've got to be efficient because I don't want to go ahead and tax the finite resources we actually have. I may not have that same problem in the cloud. I may not have the issue of finite resources because everything's infinitely scalable in theory. Now, the problem with that is, one, when it becomes infinitely scalable, all of a sudden your costs spiral out of control. But two, does inefficient code and inefficient data storage techniques in a hyperscaler also create unnecessary greenhouse gas emission as well? So while I think the hyperscalers do some incredible things by giving access to technology and accessing to compute, when you need it, sometimes that freedom, that ability to create very, very quickly, may not necessarily be thinking about it from the best possible impact, right? I mean, it'd be great to be able to see that, as somebody goes and creates an instance of a virtual machine or a compute resource, there's very, very clear indications as to what is the environmental impact that it will actually have. Like, that might be the way we need to sort of go. And certainly I think it's the same sort of thing that we need to look at tools and technologies inside our own private data centers and what we can do. My vision, what I'd love to be able to see, and you'll all probably remember, there was a period of time when we were looking at IT and saying, well, how can we actually put cost controls into private data centers? And at a departmental level, we can say, what is your percentage of costs that are being generated from our technology usage? And sometimes you heard of people talk about chargeback and things like that. Now, I think that was a great initiative. I'm not sure how successful it was. I've heard some organizations have been successful and some not so much. They couldn't really get it into effect. But maybe is that same approach, or that those same sorts of tools, can they be extended to do chargeback from an environmental point of view? What is this organization's or this department's carbon creation in the operations that they're actually doing? Like, is our sales department more a greater contributor to greenhouse gas emission based on their data center usage versus what our marketing department might be? Those sorts of tools. And maybe that is the angle to get people to be more consciously aware of, the resources they're using and what it actually means from an environmental point of view. So I think there's still things that we can do and technologies that we can actually innovate in to help companies be more aware of their consumption. Like I say, the things we do in the private data centers, things we can do in the hyperscaler. There's no one place which is going to be completely absolving us of any responsibility. We still need to be responsible no matter where our workloads actually are. Last thing I'd actually say, again, as a final thank you, I'm going to actually refer to the work being done by SNIA. This is actually a document back from 2008, so we talk about 15 years ago. The best practices listed out by this particular document produced 15 years ago is actually still very, very relevant today. So if you get a chance, go and have a look at this best practice document. There are fundamentals in here that I really believe that we can still apply to today's data center environments to help us to reduce the environmental impact of our data centers. And it's very, very specifically around data center storage operations and how it actually impacts the environment. So really, really great document to be able to reference. That's it from me. And I think we're probably very, very close on time. These are my details. If you have any questions, my email address is matthew.hardman@hitachivantara.com. My LinkedIn account is HardmanM. You can find me on LinkedIn. And also I publish on Medium if it's something that you're interested in. I don't just talk about sustainability. I actually talk a lot about different technology and productivity tools and things like that. I use that for fun. But if you want to sort of share ideas, it's definitely a cool place to go ahead and actually hang out. So with that, I'll leave the screen up there. Any questions that anybody actually has? We can come off mute or anything they want to answer. It's all very quiet.
Matthew, I think the audience can just drop the questions on the chat.
Oh yeah, I've got
Kalyan,
one here. I'll read that one out. So great session. Thank you very much. Really appreciate the feedback. What are some of the top few incentives for storage vendors to invest in technology to score high sustainability? Actually, that's a really interesting point. Like, what's in it for the vendors? I will tell you very, very plainly, the more I speak to end customers, the more I'm seeing them actually saying, look, this sustainability is very, very real. In fact, even again, like last week, I said I was in Japan, EBC. I was talking to one of the global systems integrators, the GSIs, and obviously, they're the sorts of organizations that work across a large number of different technology vendors. So, data center technology, software, and things like that. And the feedback they gave me was that the aspect of sustainability is coming up more and more and more in all of the conversations with customers. And now it's not just conversations, it's manifesting into the tenders that they're putting out to the public. And I'm not too sure about the wording, but they're saying, sustainability factors and a vendor's commitment to sustainability and maybe the measures around it, it is now coming up in their tenders. So I think what we are starting to see now is very much a recognition from customers that they need to have like they're trying to pursue their own goals in sustainability, of course. So if they're going to work with a customer, they're going to procure services or infrastructure from vendors, they want to see their commitment to sustainability as well, because what we produce as a vendor, and I work for a vendor, when you're a customer, I am contributing to your scope 3 emissions, right? So my practices about how I produce technology and all the way through my own distribution chains, my distribution centers, my manufacturing, all of those things count to scope 3 emissions. So, vendors, storage vendors, data center vendors, whatever, absolutely have to really think a lot better about sustainability because they are part of an organization's scope of emissions. So that's why it's important for them to be able to invest in this particular space. So I hope that answers the question. I get really excited about that, especially when we talk about different scopes of emissions and where you can actually have that impact. But yeah, that's why they need to be able to go ahead and actually get involved. Any other questions?
There's another one from Piyush. Matthew, you would like to answer that? It's the same.
That's the one I just answered.
Yes.
Thanks, Piyush.
Hey, Matthew, thank you. I think that's about it.
Awesome. And I just want to say thank you so much. Again, to be the first one after a year, it's an incredible honor, and I really, really appreciate the opportunity to be able to share something which I'm super passionate about. I'm hoping everybody else is passionate about as well. Like I sort of say, it starts with what we can do at the home, but I think we're starting to get somewhere with an industry where we can actually really have a tangible impact on a much greater scale. So thank you so much for being here, because your presence obviously means that you care about the environment as much as we do. So thank you very much for the opportunity.
Yeah, I'd like to thank you from the audience side, Matthew. It was a really great presentation, and we hope we have a lot more coming from you in the future days.
Thank you. I would love to be able to come back, that's for sure. I really appreciate it.
Yes. Thank you so much.
Thank you.